In this video, we will discuss about site-specific sialylation of B4ST6FC. B4ST6FC is the combination of two engineered antibodies, and that in together will cause anti-inflammatory response. In the previous video, we have understand that it's the enzyme activity that is responsible for anti-inflammatory response rather than the glycan structures. So here they need to check whether it's these antibodies will cause the site-specific glycosylations in the carbohydrate structures, or that will cause this anti-inflammatory response, or it's the silations by these enzymes is not site-specific. So first they run this antibodies along with the controls such as PBS and IVIG in a mouse models, and then check the glycan structures that have sialic acids and that does not have sialic acids, or the total glycan structures in the serum IgG they check. And what they find out is that the ratio of this monosilated by aglycosylated is similar, is not significant in all the three cases. And when they check it for this joint IgG, they can see that there is an increase in the monosilated structures in the B4ST6FC compared to the PBS. And once they evaluated that is the joint IgG, there is a change in the joint IgG, they also check this total glycan structures in the serum IgG where they treated the cells with NTN, or we can say that the mouse has not cells, the mouse already have this inflammatory disease. Mouse already had the inflammatory disease, that is NTN, and in those mouse samples they use this PBS, IG and B4ST6 to check the glycan structures of silated glycans. And what they find out is that in the total glycans they do not see any changes. So overall they do not see any changes in the glycan structures. However, when they check it for the glycan structures of the kidney, they can see that there is a significant changes in the B4ST6 B4ST6FC mouse models. And similarly similar results are shown for in the supplemental figures, where they compare the kidney IgG in the mice models that is not affected with the NTN and the mice model that is affected with the NTN, and then treated with B4ST6FC. So when there is no NTN induced, they cannot see any decrease, any significant changes in this disilated structures by aglycosylated structures ratio. However, when they introduce this B4ST6FC, they see the change in the glycan structures between the kidney and liver of the same mouse models, that from the kidney there is a more monosilated structures are formed compared to the liver, indicating that the site-specific silations are occurred at the kidney level when the mice is affected with this NTN disease that cause inflammations. And the immunoblotting results shows that the human IgG are only present in these mice models that are treated with IVIG, whereas mouse IgGs are present in all the samples, indicating that it's the endogenous IgG silation occurs. Endogenous IgG silations occurs in the mouse models rather than the IgGs that comes from external sources or the external IgGs. So from these results, the final outcome is that site-specific silation occurs based on the site of these inflammations, such as in this case the mice that are affected with this NTN shows high monosilated glycans and the kidney organs can then compare to the liver. And also these endogenous silations are more prone to occurs, as it will have more anti-inflammatory response compared to the IgG that comes from the other organisms. So I hope you understood how they study the site-specific sialations of this B4ST6FC and what are their final outcomes. If you want to understand this experimental results in detail, you can go to the reference that has been provided in the description. So these panel A, C, E, G are the HPLC of the glycans. If you need to understand more about this topic in detail, you can go through the reference that has been provided in the description. That's all for this video. Thank you for your time.